Welcome. In this brief video, I will detail one of the most common techniques of signal manipulation into the analog world. So this technique is known as a span and offset or offset and span circuit. So what is an offset and span circuit and why we need one? We need one because most of the time, what is called the span of a sensor, which is basically the difference between the full scale output and the offset. In other words, this quantity here, not usually in voltage, while, for example, a physical quantity, like in this case, pressure, and the offset, which is for the minimum input, usually 0, what is the voltage we read, or by definition, the output of the sensor without any applied stimulus. So both span and offset of a sensor, they will normally don't fit the next stage of the measurement system. And in particular, they never fit the analog to digital converter input. And this is probably one of the very first issue that you need to face for your project. So typical example, you have a sensor with an output that goes into a negative space and an A to D that cannot take negative input. So because the A to D has a range of up to 10 volt, like in this example, while our range here in total is 600 millivolt, that will require an amplification. And of course, will require an offsetting system to balance out the minus 100 millivolt and make them to equate to 0. The easiest way to make an offset and span circuit is to use the summing amplifier. And usually an inverter that is required because the summing amplifier is an inverting circuit. So in this slide here, it is recalled what is the inverting circuit and the summing amplifier. What we're going to do, we're going to select, for example, for V1 or sensor that has a different offset and span, and for V2 and V3, or sometimes only V2, the proper DC value that we need to add. So what I'm going to do now, I'm going to change sharing. Because I want to go straight into a circuit. So what I've done here, I have solved one of the typical offset and span. You have several other videos on views on offset and span, and I invite you to go and look at those. What I would like to highlight here is that the offset is being achieved using the amplifier U2 that divides the voltage, and 5 volt is not the case. The 5 volt voltage to achieve a specific offset voltage. And this offset voltage is amplified with a gain that is simply 5 kilo ohm divided this resistor, 833 ohm, while the sensor has a gain of 5 kilo ohm divided 1 kilo, and of course is inverted. So obviously you can balance and change the ratio of these two resistors, for example, using a potentiometer. And of course you may need to change the value of this resistor here. And of course, the ratio of the gain for the sensor. to fit any specific problem you might have. And there are several examples on views. This typical example here is actually what is implemented in also Tinkercad. And the reason why I say the 5 volt here is not a case, that's because usually the Arduino is powered by the 5 volt. Although in this example, I'm not using the 5 volt from the Arduino, but I'm using a power supply for the amplifiers that probably will be plus and minus 10 volt or 12 volt, because this amplifier here, it is actually the LM741. So in Tinkercad, the only amplifier that you have for your simulation is the LM741. So I will not run this simulation. I'll leave you as exercise, and in particular, leave it as exercise any kind of offset and span that I'm going to suggest into an announcement. And that's all for this brief video.